Let's do a quick refresher on how to add fractions. So here's a complicated algebraic fraction problem. You just need to add these two together. And remember, you have to find a common denominator. This gives a lot of students trouble, so let's see how to do it. And before we actually do this problem, let's work back and let's try to do something much easier. Let's just try to solve a simple arithmetic fraction problem. So 3 halves plus 4 fifths. You can't just add 3 halves to 4 fifths. As they say, that's like adding apples and oranges. Here the apples happen to be halves and the oranges happen to be fifths. We have 3 of the halves and 4 of the fifths. In order to make any sense of this, how to add these, we need to convert both fractions into the same type of thing. So instead of halves, we want to figure out how many tenths we have. Well, we multiply top and bottom of the 3 halves by 5 to get a common denominator of 10. So that would be 15 tenths. And how many tenths is 4 fifths? Well, we need to multiply the bottom by 2, so we multiply the top by 2. We get 8 tenths. And 15 tenths plus 8 tenths, well, we have, the answer will be some number of tenths. How many of them do we have? 15 plus 8 is 23. Okay, hopefully that is very much review, how to add fractions with numbers in them. The problem comes in when we have algebraic stuff in here, like x squareds and sines of x's and things like that. It doesn't matter what they are. In fact, we should be able to do it with just random symbols. So here I have a fraction addition problem. Triangle over square plus star over squiggle. We should be able to add these fractions. We need to find a common denominator. Now, I have no idea what square and squiggle are or how they're related to each other, so let's just multiply the two denominators together to figure out the common denominator. Because I can always get the product of the two denominators in my problems. So the first fraction, I'm going to have square times squiggle. If I multiplied the bottom by squiggle, there's a times between those two, I just multiply top by squiggle as well. So I get triangle times squiggle. That's my first fraction. I still have plus. And now for my second fraction, I had the squiggle there already, and I had star on top. And now I need to multiply top and bottom by the same thing. In this case, that's square. So square on top, square on bottom. So now I have two fractions, triangle times squiggle over square times squiggle plus square times star over square times squiggle. But now the denominators are the same, so I can say how many of those I have. My new denominator of the sum will be the common denominator, square times squiggle, and in the numerator I'm going to have, well, triangle times squiggle plus square times star. Okay, and that's the answer. Of course, if these were numbers or algebraic expressions, we could simplify them perhaps. But that's how you add two fractions. Alright, well, let's go back to our original problem and see if we can solve x squared over x squared plus 1 plus sine x over x cosine x. Why don't you pause the video and try on your own, and then we'll come back and I'll show you how to do it if you get stuck. Alright, hopefully it worked, but just to check our work, let's go through this. I have in the denominators an x squared plus 1, and I have an x times cosine x. A common denominator could be just the product of those three items, the x squared plus 1, the x, and the cosine x. If I want to get the x squared plus 1 times x times cosine x to be the denominator of my first fraction here, I need to multiply the denominator by what I'm missing, that is the x and the cosine x. And if I multiply the denominator by that, I have to multiply the numerator as well. So, if I do that, I get, well, I have the x squared plus 1 from before, and since there's a plus between those two, I'm going to put parentheses around it, and then I multiplied by x and by cosine of x. And in the numerator of this fraction, I still have my x squared from before, but I also have that x from this down here and the cosine x. I multiply down there. What I'm really doing is multiplying by 1, so I'm not changing the value of the fraction. My second fraction, well, my denominator here, I had an x times cosine x, and I'm missing that x squared plus 1 term. So, in parentheses, x squared plus 1. That means I'm going to have to multiply the numerator by x squared plus 1 as well. And of course, I still had my old numerator, sine of x there. and it's a product of those two, so multiply. Okay, so now both my fractions have the same denominator, so I can just go ahead and add the numerators together. And to do that, I just write the two numerators down, x squared times x times cosine x, plus sine x times, in parentheses, x squared plus 1. And then for my denominator, I have the common denominator. So that is, in parentheses, x squared plus 1 times x times cosine x. And there I've added the two fractions. Now once you get to this point, you may be able to simplify a little bit. I see right here I have an x squared times an x. That would be an x to the third. And that looks like about it. Maybe I could distribute the sine x to the x squared and the plus 1. Notice I cannot cancel anything as it stands right now because I have that plus sign in between there. Also, you can't cancel the very beginning here, right? X squared over x squared plus 1 does not simplify to just be 1. Alright, well there is how to add two fractions. Of course, subtraction is exactly the same thing, only in that last step would be a minus between the two numerators instead of plus. Okay, well I hope this has helped, and thanks for watching.